Mthly life annuities. When we are talking about the Mthly cases, it means that the payment is made more than one time per year. So let's assume that, for examples, I'll assume that the payment is $1 per year, and then it is made for 4 times per year, quarterly. How are we going to get the APV of this kind of payment? So let's draw the timeline. You are going to have from 0, let's say 1/4, 2/4, 3/4. This is 1 year. This is 1/4, 2/4, 3/4, and then it will be 2 years, and it will continue forever if it is whole life. If it is up until, let's assume it is up until whole life. If it is up until end term, so the last payment would be here n minus 1/4. Okay, so the amount of the payment, it says $1 per annum. So if it is annuity due, it will start at the beginning of the first quarter, which would be payment of 1/m. For this case, it will be $1/4. Here it's gonna be 1/4. Here 1/4, 1/4, 1/4, and so on. Discount factor would be, this is 1, B 1/4, V 2/4, V 3/4, V 1, and so on. Okay, so the probability of receiving this would be 1. Receiving this would be 1/4 px. Here would be 2/4 px, 3/4 px. Okay, here will be px, and it will continue. So the APV for this case would be summations of this plus this plus this, and so on up until infinity. You are going to get 1/4 plus, for this case you are going to get 1/4 v to the power of 1/4 1/4 px. The third term would be 1/4 v to the power of 2/4 2/4 px, plus, and so on. This one I can rewrite it in a simpler way, which is equals to summations from k equals to 0 up until infinity, 1/4 v to the power of k/4 px. So if it is for different times of payment, for example quarterly, semi-annually, or maybe monthly, then you are just changing the 4 to the more periodic, the period that you are looking into. Okay, so in general, this kind of insurance, we denote it as A double dot X M, which is equals to 1/m summations from k equals to 0 up until infinity v to the power of k/m px. If you have up until n years only, so that means that this will be the final year of payment. Okay, so you are going to get n minus 1/4 here, still payment 1/4 v to the power of n minus 1/4. This one is n minus 1/4 px. So this will be the final term. So you are going to get here for term will be a double dot x up until n m. Still the same thing, it's just that now you have 1 over m summations b to the power of k over m px, your k starting from 0 up until the last one is mn minus 1. If you want to look into the annuity immediate, annuity immediate a xm is equals to a double dot xm minusing the first term here, because that will be the only difference between whole life of immediate and whole life of due. The rest will continue forever until infinity. So it will be minusing 1 over 4. So if you look into the term case, it will be the first and the last term will be different. So you are going to get a double dot x and m minusing the first term plus with the last term, which is, since I'm using m, so here also m. Okay, 1 over m plus the last term would be Vn and px times with 1 over m. And for the deferred case for the annuity immediate, still similar, it's just that the period would be starting from, the payment of the period will be starting from here rather than here. So you are going to get n deferred a double dot xm minusing with 1 over m Vn and px. To see it clearer, you draw the timeline to compare each of these annuities. Thank you.